to Honors, Lesson 1-1, Properties of Real Numbers. Alright, here are today's objectives. Alright, moving on. Alright, here's some key vocabulary that you need to know for the lesson. Alright, the first one, alright, is natural numbers. Natural numbers, alright, start with the number 1, then you have 2, 3, 4, 5, 6, etc. Whole numbers, you include the number 0, then you have 1, 2, 3, 4, 5, etc. Integers, we begin to include the negatives, so you have -2, -1, 0, 1, 2, etc. Now rational numbers, we begin to include fractions, and decimals, and they could also be negative too, that's okay. So rational numbers, we begin to include the fractions and the decimals. Now one thing about the decimals, the decimals for rational numbers, they terminate, meaning they end. For example, 1.4, that's a terminating decimal because it ends, or they repeat. Let's say you have a decimal such as 0.33 and it just keeps repeating. This is a repeating decimal. So for rational numbers, remember the decimals, they have to either terminate or they repeat. They terminate or they repeat. Okay. Now irrational numbers right here are irrational numbers. You have square roots, and they could be positive or negative, or they could be cube roots. Okay. So basically you have to square roots, cube roots, etc. And pi is also an irrational numbers. Now irrational numbers are, pi is an irrational number because we know it as 3.14, but it actually goes on forever. Decimals that go on forever are irrational numbers. If you take square root 3 or negative square root 3 and you put it in a calculator, you get a long decimal that goes on forever and it never repeats. So decimals that go on forever and never repeat are irrational numbers. If you take any square root that's not a perfect square, square root 3, square root 5, square root 7, and you put it in a calculator, you're going to get a long decimal that goes on forever and it never repeats. Okay, that's an irrational number. Okay, so square roots, pi, these are examples of irrational numbers. Now real numbers, real numbers include everything here. So real numbers include everything, all these different number sets. So they include negatives, they include fractions, they include irrational numbers, square roots, they include positive numbers, 0. So basically all these different number sets are included in real numbers, or they're known as real numbers. Okay. A few properties that we need to go over. The closure property, for addition and multiplication. All this says here is if you take two numbers and you add them together, you're going to get a real number. If you take 2 plus 3, you get 5. 5 is a real number. Over here, same thing for multiplication. If you multiply two numbers together, you're going to get a real number. 2 times 3 will give you 6. 6 is a real number. The commutative property, just remember the commutative property is a change in order. You notice here the order changes. A plus B, and then on the other side of the equal sign you get B plus A. There's a change in order. A times B, then on the other side it's B times A. There's a change in the order. For the associative property, there's a change in grouping. Meaning what's inside the parentheses, what's being grouped, changes. On the left side here, we're adding A plus B first, but on the right side here, we're adding B plus C first. Okay. Over here, we're multiplying A and B first. On the right side, we're multiplying B and C first. Okay, so there's a change in grouping. Okay, but just be careful. Just because you see parentheses doesn't mean it's the associative property. You have to really make sure there's a change, all right, in the grouping. All right, what's inside the parentheses changes. The identity property for addition and multiplication. All right, so a plus what is going to give you a? Well, 0. Okay, 0 plus a, all right, gives you a. All right, a times 1 gives you a. 1 times a gives you a. So think of identity. All right, identity is kind of yourself. You get the same thing. Right? So you just notice here, over here, a plus 0 gives you the same thing. You're getting the same thing again. Right? So think of identity as the same thing. Right? You're getting the same result again. Right? Yourself. Inverse. All right. Inverse right here for addition. All right, is the opposite. So the opposite of a is negative a. Okay, the opposite of a is negative a. All right. Now the inverse for multiplication, all right, is not negative a, it's 1 over a, all right, or the reciprocal, all right, 1 over a. That's known as the reciprocal. Okay. Now the distributive property, all right, I'm sure you all know right here. You just take a, multiply with b, multiply with c, you get ab plus ac. Okay. Alright, so let's go over some examples here. Say we have a number line. Alright, say here's 0, here's 1, here's 2, here's 3, alright, negative 1, negative 2, negative 3. Alright, so we need to grab negative 3 over 2. Well, that's a improper fraction. Right? So let's change it to a mixed number. The same thing as negative 1.5. So where's negative 1.5? If we're going to plot negative 1.5 on the number line that we made, right, it's going to be, here's negative 1, negative 1.5 is going to be right there. Right. How about 1.7 repeating? Right, 1.7 repeating, here's 1.5. So 1.7 would be a little bit after that, repeating, so it'll be about right there. Right. Square root 5. Alright, how would we graph square root 5? We all know square root 4 is equal to 2, right? So square root 5 is going to be a little bit more than 2, right? So we're going to plot that. It's a little bit past 2, right? And that's going to be square root 5, okay? So this is square root 5. This is 1.7 repeating, alright? This is negative 3 over 2, right? Ordering root numbers. Well, let's take the square root of this. All right. So negative. All right. The square root of 0.25 is 0.5, and make it negative. The square root of 0.01 is going to be 0.1, and make it negative. Now let's compare these two. All right. Is negative 0.5 greater than or less than, right, negative 0.1? Okay. So let's think of a number line. Okay. So negative 0.5, here's 0. Here's negative 1. Right? Negative 0.5, right, is right here. Right? Negative 0.1 is right here. Okay. So you know this is smaller than negative 0.1. Right? So if it's smaller than, it's less than, right, negative 0.1. There you go. Alright, find the opposite and reciprocal of each number. Alright, so the opposite of this would be 3.2. Okay, and let's take 3.2. Alright, change it, alright, to a fraction. Alright, to find the reciprocal, we need to find the reciprocal. Let's change this to a fraction first. Alright, so 3.2 is the same thing as, alright, 3.2. Let's make it a fraction. So we're going to put it, alright, over 1. Move it decimal 1 time. Move decimal 1 time. So this is the same thing as 32 over 10. Right? That would also give you 3.2. So the reciprocal of 32 over 10 is going to be 10 over 32. And then let's just reduce this. Alright, we could divide top and bottom by what? Let's see we divide by 2. What are we going to get? 5 over 16. There we go. Alright, over here, what's the opposite? The opposite is negative 3 over 5, and the reciprocal is going to be, alright, negative 5 over 3. You notice the reciprocal, we kept the sign the same. Alright, the sign does not change when we're doing the reciprocal. Alright, so keep a note on that. Alright, let's identify properties of real numbers. Alright, right here we have 6 plus negative 6 is equal to 0. Alright, so 6 plus negative 6 is equal to 0, so that's the inverse property of addition. Alright, over here you have negative 4 times 1 minus 2, right, is equal to negative 4, right, minus 2. Right, this is the identity property, right, of multiplication. Right, the identity property of multiplication. Okay. Finding the absolute value. Alright, absolute value. Alright, these big bars here mean absolute value. They represent absolute value. What that means is whatever's inside here, alright, the final value of it, alright, you're going to make it positive. Okay, you're going to make it positive. Alright, so the absolute value of negative 3, alright, is going to equal 3. The absolute value of 3 would also equal 3. Alright, it doesn't mean opposite. It means whatever's inside, alright, you make it positive, is going to become positive. Now let's say it's something like 4 minus 6. Alright, you've got to work this out first. This gives you negative 2. Alright, and the absolute value of negative 2 gives you 2. So whatever your final result is, just make it positive. Alright, so over here the absolute value of negative 4 is, alright, is going to equal 4. The absolute value of 0 is 0. Alright, over here multiply this first. This will give you positive 2. The absolute value of positive 2, alright, is going to be 2. Okay? 100% Honors Lesson 1-1, Properties of Real Numbers. Here are the lesson's objectives. Alright, some key vocabulary, alright, that we're going to need to know for the lesson. Alright, the first one, alright, natural numbers. Natural numbers begin with the numbers 1, 2, and 3. Okay, and they go on 4, 5, 6, etc. Whole numbers, alright, include the number 0, and then 1, 2, 3, 4, 5, etc. Integers, we're going to include the negative numbers, alright, so you're going to have negative numbers, alright, so negative 2, negative 1, 0, 1, 2, alright, so just remember integers, that's when we begin to include negative numbers. Now, rational numbers, we're going to start to include fractions and also decimals, alright, and the fractions and decimals can also be negative, okay. So rational numbers, we include the fractions and the decimals, and one key thing to remember, alright, about rational numbers, the decimals, alright, they either terminate, meaning they end. For example, 1.4, that's a terminating decimal because it ends, right? Or they repeat. Alright, so let's say you have a decimal like 0.33 repeating. Alright, that's what this bar means right here. It means that the 3 will repeat. Alright, so rational numbers, the decimals have to either terminate or repeat. Irrational numbers. Irrational numbers are square roots, and they could be positive or negative, or they could be cube roots. Okay, and also pi is an irrational number. It's an irrational number because pi, even though we know it as 3.14, it actually goes on forever. Alright, there are a lot more. Alright, it goes on forever. Alright, that's why it's an irrational number. So decimals that go on forever and do not repeat and do not repeat are irrational numbers. So pi is an irrational number. Okay, square roots. If you take a square root, for example, square root 7. If you take the square root of 7 put it in a calculator, it's gonna give you a decimal, that doesn't repeat, and it goes on forever. So that's an irrational number. Now all these different number sets together, form the real numbers. Okay, so when we talk about a real number, we could be talking about any one of these different types of numbers here. So all these number sets form the real numbers. Okay, so just remember that real numbers include all of these. Properties of real numbers now. The closure property for addition and multiplication. All this says is a plus b will result in a real number. For example, 2 plus 4 gives you 6. That's a real number. 2 times 4 gives you 8. That's a real number. So that's the closure property. The commutative property. Just remember the commutative property is a change in order. You notice here the order changes. A plus b, then over here it's b plus a. So the order changed. A times b, and over here it's b times a. So when there's a change in order, it's the commutative property. Over here, the associative property, just remember there's a change in grouping. So over here we have a plus b, that's in parentheses. Then over here we have b plus c, that's in the parentheses. So what was inside the parentheses changed. That's a change in grouping. Over here we're multiplying a and b first. Then on the right side we're multiplying b and c instead. So there's a change in grouping. That's associative property. Just be careful. Just because you see parentheses doesn't mean it's the associative property. Okay. The identity property of addition. A plus 0 gives you a again. 0 plus a gives you a again. So identity, meaning identity is kind of like the same thing. So a plus 0 gives you the same thing again. 0 plus a gives you the same thing again. So just remember, if you add or multiply to get the same thing again, that's identity property. Down here, inverse, a plus its opposite gives you 0. A times 1 over a equals 1. So a plus the opposite gives you 0. So for addition, you're adding the opposite to get 0. Over here, in order to get 1, you're multiplying by 1 over a, which is known as the reciprocal. This is the inverse property. The distributive property, I'm sure you all know. Just distribute, multiply here and here, you get ab plus ac. Alright, let's graph some of these numbers on a number line. So let's make a number line real quick. 0, 1, 2, 3, -1, -2, -3. Alright, so -3 over 2. Alright, -3 over 2 is an improper fraction. So let's change this to a mixed number. This is equivalent to -1.5. So where's the -1.5 on our number line? Alright, -1.5 is going to be right there. So there's -1.5. Alright, how about 1.7 repeating? 1.7 repeating, well, that's more than 1. It's more than 1.5, so a little bit more than 1.5, we're looking at about right there. Okay, and square root 5, well, let's think. We know square root 4 is equal to 2. So square root 5 has to be a little bit more than 2. Right? So square root 5 is going to be a little bit past 2, so we estimate about right there. Alright, so this is square root 5. This is 1.7 repeating. Alright, and right here, this is -3. over 2. Right? Ordering real numbers. Alright, first of all, you have to remember the symbols. Alright, this is the less than symbol. Alright, this is the greater than. Alright, just remember the less than is kind of like a crooked L. Okay, less than symbol looks like a crooked L. Alright, so right here, so first we need to simplify these two square roots first. So the square root of 0.25 is going to give you 0.5. Then you have the negative out here, so make it negative. Over here, the square root of 0.01 is going to give you 0.1, right? And then you have the negative out here, so you have the negative out here. Now let's think. Right, if we have to, you could draw a little number line, right, to help you decide which one's bigger, which one's smaller. So say here's 0, here's negative 1, right? So negative 0.5, so that's negative half. Right, negative 0.5 is going to be right there. That's where negative 0.5 is. So this is negative 0.5. Negative 0.1, right? Negative 0.1 is going to be about right there. Right, it's a negative 0.1. Right. So which number is bigger? Now remember, on a number line, right, all the numbers to the right of a number are bigger than it. Right. So this number is bigger than this one, right? Because it's to the right of this number. Right. So negative 0.5 is less than negative 0.1. Find the opposite. All right. So the opposite of this is real easy. Right. So that would be 3.2. Right. Now the reciprocal. Right. The reciprocal of this. Well, we've got to make this into a fraction first. 3.2 is the same thing as 32 over 10. Alright, 32 over 10. If there's one number behind the decimal, just take this number, put it over 10, because there's 1 0 behind 10. So 32 over 10, let's reduce this first. Divide top and bottom by 2. You get 16 over 5. Now since we want the reciprocal, we got to flip this, so the reciprocal is going to be 5 over 16. Okay? Over here, the opposite is going to be negative 3 over 5. And the reciprocal is going to be negative 5 over 3. Now you notice for the reciprocal, it was still negative. Alright? When you're doing the reciprocal, you don't change the signs. A lot of students make the mistake and they change the signs. Okay? When you're finding the reciprocal, just flip the fraction. Alright? The sign stays the same. Properties, identifying properties. Now basically you just kind of have to memorize the properties we talked about earlier. You have 6 plus negative 6 equals 0. Right? Well, remember, a number plus its opposite that gives you 0, that's the inverse property of addition. Okay? Negative 4 plus 1 minus 2 is equal to negative 4 minus 2. Right? Well, basically you're multiplying. Now since 1 is inverse, is a reciprocal, is also 1 over 1. So this is the identity property of multiplication. Identity property of multiplication. Okay. Let's come up with some more examples. Let's say we have 1 plus 2 is equal to 2 plus 1. What property would this be? Well, it looks like there's a change in order, so this would be commutative. Property of addition. Okay. Now say we have 1 plus 2 plus 3 is equal to 1 plus 2 plus 3. What property would this be? This would be the associative property of addition. Because it's a change in grouping. 1 plus 2, 2 plus 3. Now, what property would this be? Let's see. 1 plus 2 plus 3 is equal to 3 plus 1 plus 2. Alright, so let's think. Alright, is this associative property? Alright, well, is 1 plus 2 over here, is 1 plus 2 over here. So there was not a change in grouping. Alright, so the grouping stayed the same. What changed was the order. 1 plus 1, 2, 3, 3, 1, 2. So this is a change in order, so this would be commutative. Alright, so this example when I told you to be careful, just because you see parentheses doesn't mean it's associative. Alright, it's commutative property. Okay, so just be careful. Alright, finding the absolute value. Alright, to find the absolute value, first of all, these big bars mean absolute value. Yeah, and what that means is whatever the final value inside here is, just make it positive. For example, the absolute value of 6 is going to be equal to 6. The absolute value of negative 6 is going to equal 6. So it doesn't mean opposite, it means whatever's inside here, make it positive. Alright, now you have to do some work. Let's say, for example, 8 minus, let's say 3. Alright, just work this out first. That gives you 5. Absolute value 5 is 5. Alright, whatever you're left with here, make it positive. Alright, so down here, the absolute value of negative 4, well, that's 4. The absolute value of 0, that's 0. Alright, you have to multiply here first, that'll give you 2. The absolute value of 2, that's going to equal 2. Alright, whatever's inside here, make it positive. Okay.